In this video, we're going to discuss sine and cosine and how we use the unit circle to find the values of sine of certain angles and cosine of certain angles. So recall back, hopefully from your geometry class, and if not, we're going to discuss this further. But sine of an angle is equal to the side opposite that angle divided by the hypotenuse. And cosine of an angle is equal to the adjacent side to that angle in the hypotenuse. In the unit circle, we discussed certain coordinates already, these four here in particular. You'll notice there are additional coordinates. These are the coordinates in the coordinate plane along the unit circle at those specific checkpoints for 30 degrees, 45 degrees, and so on and so on. So when you're seeing like 30 degrees, pi over 6, and then the square root of 3 over 2, 1/2, these are just actual coordinates in the coordinate plane. So let's discuss how we're going to use those coordinates along with sine and cosine to determine sine of certain angles and cosine of certain angles. So let's start with this. If we wanted to find sine of 60 degrees, that is the same thing as finding sine of pi over 3. Notice how 60 degrees is equivalent to pi over 3 radians. So what I want to do is take this coordinate and create a right triangle. The hypotenuse of this triangle would have a length of 1 unit, because remember, that is just a radius. That is a radius in the unit circle. This angle here is 60 degrees or pi over 3. So imagine if I wanted to find sine of that angle. Sine of that angle of 60 degrees would equal the opposite side over the hypotenuse. So let's talk about what that would actually be. The height of this side is the same thing as this y coordinate. Remember, y gives you the vertical height in the coordinate plane. So the opposite side has a length of square root of 3 over 2. And the hypotenuse, as we just discussed, has a length of 1. This is square root of 3 over 2 divided by 1 is square root of 3 over 2. Notice how sine of 60 is the same thing as sine of pi over 3, and it equaled this y coordinate. That's going to be important in a second. Let's now talk about cosine. Say we wanted to find cosine of 240 degrees. That's the same thing as cosine of 4 pi over 3. And so I'm going to create a similar right triangle. So imagine if this was our theta. We know cosine is equal to the adjacent side over the hypotenuse. Well, we know the length of the hypotenuse, remember this would be the hypotenuse across from the right angle, is just 1 unit. We want to know the length of this side here, the length of the adjacent side. Well, that is just equivalent to the x coordinate in the coordinate plane. We would move left -1/2. So the adjacent side has a length of -1/2. Cosine is adjacent over hypotenuse. -1/2 over 1 is -1/2. Notice how that is the same as this x coordinate. That's an important idea. Using right triangles, we gather that sine of an angle is equal to the y coordinate. Cosine of an angle is equal to the x coordinate. Make sure to make note of that. Cosine of an angle using the unit circles equivalent to the x coordinate, and sine of an angle is equal to the y coordinate. I also want you to note that when we're given angle measures, the way we find that position in the unit circle is we start essentially with a ray at the point 1, 0, and if the angle is positive, we're going to move counterclockwise. If it's negative, we're going to move clockwise. So let's say we wanted to find cosine of 135 degrees. That's positive 135 degrees. So we're going to begin at this ray, and we're going to move left 135 degrees to make the angle. So if I want to know cosine of 135 degrees, cosine is equal to the x coordinate in the unit circle. Cosine of 135 degrees is going to be equal to negative square root of 2 over 2. That is the x coordinate. So notice there, to find 135 degrees, we moved to the left. We moved counterclockwise. If I now want to find negative 135 degrees, I need to go that same distance, but now in the opposite direction. This would be negative 135 degrees. Negative 135 degrees is the same thing as positive 225 degrees. The negative told me to move counterclockwise. Now, since I want to find sine, I need to use the y coordinate. Sine of negative 135 degrees is also, in this case, negative square root of 2 over 2. That's just because that's the y coordinate at that position in the unit circle. Let's talk now about radians. So imagine if we want to find 13 cosine of 13 pi over 6 radians. Remember to go all the way around this circle. That is equivalent to 2 pi radians. 13 pi over 6 is actually more than 2 pi. 13 pi over 6, if I tried to subtract 2 pi away from that, that'd be the same thing as 13 pi over 6 minus 12 pi over 6. Is pi over 6. So I actually need to go 2 pi around plus an additional pi over 6. So 2 pi and then an additional pi over 6. So I really want to know this angle here would be 13 pi over 6. 1 time around plus pi over 6. We want to know what is the x coordinate there, since we're asked about cosine. That would be negative square root of 3 over 2. Lastly, we're asked about sine of negative pi over 3. Well, imagine if you were asked about positive pi over 3. This would be the angle for positive pi over 3. So what we want to do is go that same distance in the opposite direction. This would be negative pi over 3 then. That angle there, that 5 pi over 3, is equivalent to negative pi over 3. Since we're asked about sine, we want to know what is the y coordinate at that position. The y coordinate is negative square root of 3 over 2. So if you're asked to find cosine or sine of an angle, then what we're looking for is the x coordinate at that position for cosine or the y coordinate at that position for sine. Let's talk now about how these relate to the quadrants. We know in the axis, in the coordinate plane, we call this quadrant 1, and then we move counterclockwise. Quadrant 2, quadrant 3, and quadrant 4. We know cosine of an angle equals the x coordinate, and sine of an angle equals the y coordinate. So in quadrant 1, x is positive and y is positive. So in quadrant 1, cosine is positive and sine is positive. In quadrant 2, x is negative and y is positive. So if you land in quadrant 2, cosine is negative and sine is positive. In quadrant 3, both x and y are negative. So this is negative, negative, meaning cosine is negative and sine is negative. And then lastly, in quadrant 4, the x coordinate's positive and the y coordinate's negative. So if your angle lands in quadrant 4, cosine will be positive and sine will be negative. So if we're asked to determine if a measure is positive or negative, or if sine or cosine of a specific angle is positive or negative, we only need to worry about what quadrant we're falling in. So imagine if I wanted to know, is sine of 348 positive or negative? Well, considering that it's 360 degrees to get all the way around, I know 348 degrees is not quite going to be all the way around. So this is in quadrant 4. And we know in quadrant 4, sine is negative. So sine of 348 degrees will be negative. Cosine of negative 115 degrees. If I went negative 115 degrees, so that would land me in quadrant 3. That's because it wouldn't quite get me to negative 180 degrees, but it's more than negative 90 degrees. So cosine of negative 115 degrees puts you in quadrant 3. Well, in quadrant 3, cosine is negative. So that tells me that cosine of 115 degrees will be negative. How about sine of 5 pi over 8? Well, we know that 5 pi over 8 is between pi over 2. So remember, this was pi over 2 and pi. This is pi units. So if I asked you about sine of 5 pi over 3, you would be landing somewhere in quadrant 2. This is in quadrant 2. And in quadrant 2, sine is positive. So in quadrant 2, sine is positive, so sine of 5 pi over 3 will be positive.